How's it going? So in this one, I want to kind of continue looking at the model accuracy and what we can do on that. So I want to look more specifically at the model this time. So if you look at these are the hyperparameters. So this is the number of iterations that we're doing. The learning rate is something that gets updated on every iteration. So these are what you can set on the model itself. And you remember how I said before, you can kind of just like, whoops, you can kind of just like do trial and error on these to figure out like what are the best things that you can do. There's actually a more efficient way to do that that scikit-learn offers you, and I can show you that this time. So I have the documentation pulled up here for something called GridsearchCV. So this is something I found out about myself not too long ago. So what this is going to do is instead of offering in just like some parameters like the number of iterations and stuff like that as static things, you can just add like you can add an entire parameter grid. So it'll run through for a number of iterations. I want to try like 10, 20, and 30. Then for the learning rate, I want to try like 0.1, 0.2, and 0.3, etc. like that. And it'll run through that with the model, and then based on the R2 scores that you get, which are sort of what you do to assess like how it's doing on the training set, how it's doing on the testing set, it can kind of figure out like what are the best parameters, the best hyperparameters that you can actually use for the model, and then it'll go ahead and train it on that. So that's what I kind of want to look at implementing in this video. So let's get into it. Before we get into the actual code, it's useful to talk about the CV part of GridsearchCV. So CV stands for cross-validation. And what cross-validation is remember that we have a train test split function, and that's basically segmenting off the data. So it's saying 25% is going to be for testing and 75% is for training. Well, cross-validation is basically going to further subdivide those into scikit-learn, reverse those as folds. So it says that like 20% of that 75% is in each of these folds, and it's going to get the R2 score for the data over each of those folds, and it's going to average them together, and that's how it's going to evaluate how it does on the training data. So that's how it's going to end up getting the score, and it's going to basically see like for every combination of parameters that we have, where is the average over all the folds performed the best? Like which combination of hyperparameters is the best? And then it's going to use that. And then it's going to come down here and do a final evaluation, and it's going to actually use those parameters and evaluate on that. And that's how it's going to build the model. That's how it's going to help improve our evaluation is we can specify many parameters and it'll just find the best ones to use out of that. All right, so now coming to the actual code. So the import for GridsearchCV is going to be in the same model selection, so we're just going to add GridsearchCV to that right there. Coming down here to our training section, this is where we want to actually insert stuff in here. So first we'll put in this parameter grid. So this is how it's going to look. So we're going to have the learning rate, the estimators, and the max depth. Those are going to be the hyperparameters that we're going to use. And then these values in this list here are going to be what we're going to want to try for each of these hyperparameters here. and then we're just printing out a simple statement of like how many total combinations that we have. I want to be a little bit verbose here and show you how it's actually working. All right, so for the actual training part, this is going to look a little bit different. So we're just going to paste this in, and then so grid search CV. Oh, whoops, I forgot one piece. The base model here. I'll explain that. So the base model is still going to be the gradient boosting regressor that we were using. This random state, I think I talked about this last time. This is basically to make it so that we can kind of replicate what we're getting. So it's not just going to be random every single time that we train the model. So this makes it better so that I can show you how it's working. And then so when we actually call GridsearchCV here, we're going to pass in the base model as our estimator. So again, we still want to use gradient boosting regressor. And then the param grid is going to be, this is just this dictionary that we specified of the learning rate, the n estimators, and the max depth. That's um how many like conditions are being used to actually evaluate this. And then the scoring is, like I said earlier, we want to use the R2 score. There are other scoring algorithms that we can use, but this turns out to be the quickest and the most accurate. And then setting CV to 5 just means that we do want 5-fold, so like on that image that I showed you before. End jobs from the documentation is just how many processes to run in parallel. By setting it to -1, we're essentially saying that we want to use all the available processors that we have, that's what we want to do. This is the only process running on this computer. And then the verbosity, again, just to show you. And then it says these are not defined. Did I? Oh, I see. I accidentally pasted over the actual training and split set. Okay, so remember this .fit function from before. This is what actually trains the model. So we're doing that same thing. We're just calling grid search for it because grid search is also able to just train our model for us using the best parameters that it's found. So you can see here too that we have the little yellow squiggle under model. So we don't have that defined anymore, and that's because what we can do, just grab it from my keyboard, is we have this code here. So the gridsearch.bestestimator, this is going to just be a reference to what we found to be the best parameters on there. So we take that, and that's how we end up doing the feature importances down here. And so lastly, before I go ahead and run this thing, I just want to include a little printing code that I had ChatGPT or Copilot whip up for me. So this is just printing out what it finds for the best parameters and the best R2 score, and then it iterates through every combination that we have, so we can actually see what the scores were for the parameters that were chosen, so we can kind of scroll through and see how they're done. So let's go ahead and save that file, and then we'll run make train. And so it's doing 480 combinations, so it's going to take a second to do that. And then we'll expand this so that we can take a look. So it finds what the best parameters are. So this is different than the parameters that we were using before. So we do expect to find something good for that. And then these are all of the R2 scores that we get for every single parameter that we have. Now, keep in mind that these are the scores on the cross validation set that we have for every combination. So that's why we have 96 candidates here. And so this R2 score, the 0.241, this is different than what we get for the training and test scores down here. And that's because this is done on the test set, this is done on the actual training set, and then these are just the averages found on the cross validation set. So the idea is by finding the best based on that, and we have the standard deviation because we have 5 folds, right? So this standard deviation is saying like this is how much variance that we have in each of these. So this is the best that it found for that. So it takes those parameters and then applies it to the training and test sets. Now these numbers are pretty cool to see, but it'd be useful to see what we had before so we can see like how GridsearchCV is actually helping us, right? So this is another bit of code that I had Copilot whip up for me, and it's just exactly what we had for the previous model. Just doing all the scoring for that, and then it's getting the it's getting the scores based on that, and then for measuring an improvement, we want to see how we're doing on the test set, right? Because that is by definition, it's data that the model hasn't seen yet, so that's what you actually want to see. So in order to see what that is, we're going to get the difference between the optimized model and the previous model for just the test score, and then we're going to turn that into a percentage so that we can see that. So then if we save that and rerun this model, or rerun the training, I guess. Okay, so you see that with the previous model, like it was actually doing pretty well on the training data. It was at about like 76% or something like that, which is pretty good. But the test data, it was only like 24%. It was not very good on that. And these are numbers that you want to ideally keep closer together, because remember, if it performs well on the training data, that means that if you think of it like you're taking a test, like you're basically memorizing the answers at that point. So you're kind of just like, if they give you questions that were on like the practice test, you can nail those, right? But if you're given like new test questions, then you don't know what to do. And with these numbers, you're almost like essentially guessing, right? So with the optimized model, these scores still aren't great, but they're closer together. You have 43% and then 34% for your testing data. So that is an improvement of like 43% here, right? So that's a pretty good improvement from there. Lastly, for this video, I just want to bring up the back end again, and then we'll test the endpoint. I don't expect to see too much to be different. So 44 was 1594. So try it again, 1487. Okay, so that's actually a little faster. With knowing the feature importance from last video, you can see that age really isn't going to have that much of an impact. It's only at like 0.3% right now or something. But for the run 400, let's see if we set this to 60, then we get a faster 5K at that point. If we set it to be slower, if we say 200, then we get a slower 5K time overall. So the numbers do look better. They still don't look completely intuitive, but this video was more of a dive into the technicalities, so like the actual model, what you can do for that, going for grid search CV to get the best hyperparameters. So thanks for watching, and I will see you in the next one.